this is section 11.4. We're going to be doing infinite geometric series, but we're going to add them up, only this time we're going to add up infinite series. So we'll talk about how you do that in just a second. The homework would be 47 through 55. So let's talk about writing the sum means add, of an infinite means keep on going forever and ever, geometric in this case means multiply by the same number each time, series using summation notation. Now summation notation uses this, kind of looks like a capital letter E. It is a Greek letter, sigma, and it means add it up. Okay, that's why we call it summation notation. So here we have this formula right here. Okay, and let's talk about the bits and pieces here. Notice underneath that sigma, I have k equals 1. That's where we start. That's the first number we start with. And at the top, we have infinity. Infinity means it's an infinite series. So keep on going forever and ever. A sub 1. A tells you that you have a sequence or series, and that 1 tells you I need the first term in this geometric series. The R is the common ratio, and it's what we multiply to get the next term. Raised, this is all one thing, raised to the k minus 1 power. Okay, now in order to take the sum of an infinite geometric series, what we need is the common ratio to be a fraction. This doesn't really work if the common ratio is, if we have r equals 7, this process won't work. If I have r equals 1/7, then this is when we use this summation notation. All right, so let's do an example. What expression represents the sum of the infinite geometric series? So notice I have my little sigma notation, sorry, and what I'm going to do is I'm going to start with k, and that k always starts with 1, and I'm going to, this is infinite, you see how you have the dot dot dot, means keep on going forever, so I need the infinity symbol on top. Alright, so let's see what we're going to put next to the sigma. The first thing we have to write is the first term. Well, the first term is 1/2. Parentheses, and the exponent is going to be k minus 1. Okay, so let's come back to the common ratio. What do we multiply each time? Well, if you notice, we have a fraction, and I know you're stressing about that, but it's not so bad. The common ratio is indeed going to be a fraction. We're going to take each part at a time. So we're going to look at the top first. Notice I have 1, and then 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 I have 1. So what number can I multiply 1 by to get 1? Well, 1. So that top of the common ratio is going to be 1. So let's take a look at the bottom. We start with 2, then we have 4, and then we have 8, and then we have 16. What are we multiplying the bottom by to get the next number? Well, we're multiplying by 2. It turns out the common ratio is 1/2. So this is one way of getting the common ratio. You need to take the second term divided by the first term. And remember, when you divide, you're going to change that to a multiplication problem. Switch the second fraction, flip it upside down, and you multiply the top and you multiply the bottom. You get 2/4, which reduces to 1/2. All right, so Either way you do it, you're going to get 1/2. I personally think just kind of looking at the numbers, see what you got to multiply by is easier than this process right here. But it's your choice. You can do it either way. And this is the answer. That's what I'm looking for. So let's do another example. This time I use I, and it doesn't matter what letter we use. Usually K, J, I, those are common ones. We're going to start at 1, and it's infinite. Dot, 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 keeps on going forever. So infinity goes on the top. We need the first term, which is 8. I minus 1. Okay. Now, these two are not fractions, but these two are. So we're going to ignore the first two, at least temporarily, and look at the 1/2 and the 1/8. Because remember how I said the common ratio has to be a fraction? Well, we got to keep that in mind. So let's just look at the third term and the fourth term. What do I have to multiply by to get the top? I go from 1 to 1. Well, 1 to 1, multiply by 1. And if you look at the bottom, you go from 2 to 8, and I multiplied by 4. Now, in order to check your answer, you're going to take the first two terms. Let's go back to the first two terms. We're going to take the second term divided by the first term and reduce it. And sure enough, we get the common ratio of 1/4. So again, I believe just looking at the numbers is easier, but you can take the second term divided by the first, and that will give you the same common ratio, however you want to do it. Let's do another example. I think we have time. X is equal to 1 to infinity. First term is 2/3 raised to the x minus 1. Now, notice, so it is going to be a fraction. Notice the signs switch. They go from positive to negative, positive to negative, positive to negative. What that means is your common ratio is going to be negative. So if the signs alternate, your common ratio has to be negative. And again, these two terms are kind of weird. You don't see a real good pattern there. It helps if you look at these two terms in order to figure out what the common ratio is. Again, I go 1 to 1, so the top fraction is going to be 1. And on the bottom, I get 2. 6 times 2 is 12. And you can verify that if you wish. Okay. Now, if I want to find the actual number as opposed to using summation notation, I use this formula right here. So I have the first term divided by 1 minus the common ratio. So if I have to add up all of the terms in an infinite, this only works for infinite, geometric series, doesn't work for arithmetic, has to be geometric. If I want to add up all of the terms of an infinite geometric series, I'm going to use this formula, s equals a sub 1 over 1 minus r. Here's an example. All right. By the way, you should kind of beef up a little bit on your fractions because you will have to do a little bit of fraction work in this problem. So we have this infinite geometric series, and I want to find the actual sum. What does it actually add up to? So the formula says I have to take the first term and put it on top. That is 12. I have to take 1, subtract whatever the common ratio is. So find the common ratio. My signs alternate, so it has to be negative. I go from 4 to 4, 4 to 4, that means I'm multiplying by 1. And on the bottom I go from 3 to 9, that means on the bottom I need a 3. 3 times 3 is 9. So as you can see, my common ratio is negative 1/3. So here is the formula. So as far as the actual process goes, you've got the sum. Now comes the part where you have to actually simplify that fraction. So let's take a look at how we would do that. If we are subtracting a negative, that turns into a plus. So right now I have 12 over 1 plus 1/3. Okay. Now remember, when you add fractions, you actually need a common denominator, and they both need to be fractions. So I'm going to put a 1 underneath that 1 to turn it into a fraction, and you can see that right here. Okay. Now these two numbers, the 1 and the 3, they have to be the same, so we need a common denominator. Common denominator we're going to pick is 3. This number is already a 3, so we have to turn this 1 into a 3. To turn a 1 into a 3, we multiply top and bottom by 3. Multiply, multiply, and we get 3 over 3. Once we have a common denominator, we're going to add the tops. So 3 plus 1 is 4, and we keep the bottoms the same, 4/3. All right, so here's where we're at right here. We have 12 on the top, and we have this 4/3 in the bottom. Now remember, every fraction problem is really division. What this fraction says, hold on. Okay, so what this fraction says is that we're going to take 12 divided by 4/3. I'm going to rewrite that as 12 with this kind of division symbol, 4/3. So right now I have 12 divided by 4/3. Okay? If you have divide and you've got a fraction, you have to flip the fraction and turn it into a multiplication problem. So 12 times 3/4. The 12 has to be a fraction. We're going to put that over 1. Multiply the tops, multiply the bottoms. We get 36 over 4. Divide. And finally, we get our answer of 9. So the actual new stuff is right here. But all this stuff in here, that's arithmetic and fractions. So the Algebra 2 part, we took care of right there. Everything else is just arithmetic. All right, so let's do an example. We need to find the sum of an infinite geometric series. So I need my first term over 1 minus r. Okay, let's take a look. The first term is 4 over 1 minus. We need to figure out what our common ratio is. You can pretty much guarantee that it's going to be a fraction, because otherwise it doesn't work. So I don't see any fraction and then another fraction, so let's see if we can get that common ratio a different way. So if it's not obvious, we got to take the second term, which is 2, and divide it by the first term, which is 4. We can reduce that to divided by 4 is 1/2. So we have a common ratio of 1/2. All right, as far as the Algebra 2 goes, we got it, but we do need to finish that out, so we got to do a little bit of arithmetic. Okay, so let's simplify this. We need to work it out. So we have 1. I have this 1, and I need to turn it into a fraction, so I'm going to put a 1 underneath. Now I've got denominators of 1 and 2, and I need a common denominator. So common denominator is going to be 2. So that means I need to multiply this fraction, top and bottom, by 2. So 4, 2 over 2 minus 1/2. Once the denominators are the same, we're going to subtract the numerators. So 4, 2 subtract 1 gives me 1. And we're going to keep the denominator the same. All right, here's where we rewrite it so it makes it easier to work out. Remember, that's 4 divided by 1/2. When we have dividing with a fraction, we're going to switch it to a multiplication. 2 over 1. 2 over 1 is really just 2. 4 times 2. Answer, the sum is equal to 8. A lot of work, I know, for one number at the end. So let's do one more example. We need the first term, the common ratio. Notice the signs alternate, so it is going to be a negative. We do have a fraction, and the tops are the same, so we got a 1 on top. If you look at the bottom, we have 3 and then 9 and then 27, so we're multiplying by 3. All right, now let's simplify. If I'm subtracting a negative, that's adding a positive, so I have 1 plus 1/3. I need to make this a fraction, and I need a common denominator, which is 3. So I'm going to multiply top and bottom by 3. I get 3 over 3 plus 1/3. Denominators is the same. Add the numerators. Now I have 4 over 3. So I'm going to rewrite that. So I have 2 divided by 4 over 3. Change it to a multiplication problem by flipping the second fraction. So now I need 2 fractions, so put a 1 underneath the 2. Multiply the tops, multiply the bottoms. You have 6 over 4, which will need to be reduced. The sum is equal to 3/2. All right, let me know if you have any questions.